Okay. I think we'll get started. We have some people coming in still, but this is actually a session that we did in the US and in Europe, and we went overtime with 75 minutes. So I have to try and pull this off in 60 minutes. So we'll see how this goes. Hi, I'm Ben Armstrong, work on the Hyper-V team. I'm a program manager, and I'm here today to talk about Hyper-V storage, specifically to talk about all the work that's gone into storage for Hyper-V in Windows Server 2012. And this has been a huge area of investment for us. It's one of our top areas of investment. And there's actually a very simple reason why. So we went out and did a survey, and we talked to a bunch of different people. We targeted the implementers. We targeted the people who are in the trenches working with virtualization today. But we talked to people across a large range of companies. And we went to them with a single question. And we said to them, what is stopping you from running more virtual machines on your current infrastructure? Whatever number you have, why aren't you running more? So they came back. Now the first thing, hopefully shouldn't be a surprise to anyone here, is no one said that CPU was a bottleneck anymore. When I started working in virtualization about 10 years ago, CPU was the number one bottleneck. No one said that CPU was stopping them. A couple of people said network. We did have some people come back and say that network was a bottleneck. We had about a third of the people come back and say that memory was a bottleneck. And this was interesting. We went and talked to those, and what we found was that in a lot of cases these people were running older hardware which didn't have large amounts of memory in it. These days you get new hardware, it's very easy to get boxes with large memory. But far and away the most common thing that held people back was storage. So we've done a lot of work around storage. Now, working at Microsoft, I get to talk to a lot of different people who are using Hyper-V and talk to them about the problems that they're having in their environment. And I have a simple statement that I like to make about storage. And that is, it doesn't matter what size your company is. It doesn't matter if you're like a Fortune 100 with multiple data centers, or if you're a mom and pop shop with 2 servers. There are 2 facts that I can tell you about storage. Fact number 1, there is a perfect storage solution out there for you. Fact number 2, it is more than you are willing to pay for. And this is true, though. I talk to small businesses, and they're complaining about the cost of storage. I go and I talk to these huge enterprises, and they're complaining about the cost of storage. And it blows my mind. I've talked to, I remember I talked with a company they had over 60 EMC SANs in their data center. And they were talking to me and saying hey, can we use Hyper-V Replica? And I'm sitting there going, no. I'll talk more about this tomorrow in my Replica session, but I'm saying no, Replica's not designed for the really big scale. We've designed it for small, medium business. In your sort of situation, you should be utilizing your SAN investment and doing SAN replication. And this guy looked at me and said, yeah, it's too expensive. I'm sitting here going, you have 60 SANs. Okay. So we've done a lot of investments across the board. And this is something that causes some confusion for people, so I'm going to cover it up ahead of time, is people always come to me at the end of this session and say, okay, Ben, what's your recommendation? What's the storage option I should choose? And the answer is always going to be, well, it depends. There are a lot of storage options out there today. They all have pros and cons. And I like to say, when it comes to storage, we're Switzerland. We're neutral. We don't actually come out and say, yeah, for Hyper-V, you should have this kind of storage. What we have done is we've actually spent a lot of time trying to make sure that whatever your needs are, whatever storage infrastructure you decide makes sense for you, Hyper-V allows you to get more money out of your investment in that storage. So you're going to see that today. I'm going to be talking about investments that we've made in SANs, in Fiber Channel, in SMB, in DAS, across the board, how we've been trying to make it so that you can get more out of your storage. So part of this has been we've enabled a whole lot more options for doing highly available storage. We've always had DAS, direct attached storage, but that's not highly available. In the past, with Hyper-V, our answer for highly available storage has been an external storage array. And it's either to use a SAN or to use an iSCSI device. So in Server 2012, we're adding a whole bunch of new options. First one, we're now officially allowing you to use SMB for storing virtual machines. We also have storage spaces, and we also have clustered PCI RAID. I'm going to talk more about all these options as we go through this deck. But the first thing I want to talk about is some of the things that we've done to take the existing models that we support and to make them better, to make them work better with Hyper-V and to better integrate into these environments. So the first thing that we've done is we've now enabled virtual fiber channel. And what this is essentially we allow you to create a fiber channel adapter inside of a virtual machine and connect it to a LAN off a SAN in your environment. And we did this for a couple of reasons. The first reason was and I said this in my previous session, one of the things we've really aimed for in this release is to get rid of that workload that can't be virtualized. And when we talk to people about, hey, are you doing virtualization? Oh yeah, we virtualize everything. Really? Well, actually, we virtualize everything except for, and the most common thing that we heard was we virtualize everything except for our SQL cluster. And when we talk to people about, hey, why aren't you virtualizing that SQL cluster? The response that came back was twofold. The first one was, you don't support enough virtual processors in your virtual machine. You only support 4, I need more. So we now support 64. The second one was, I need to have that workload clustered. You only support guest clustering with iSCSI. I'm not going to use that with my SQL server. And so that's where we went, okay, we need to invest in supporting Fiber Channel through to the virtual machine so that you can cluster these high I/O workloads and be confident in it. The second reason why we did this, and this was another piece of feedback that we heard, and just a quick show of hands, how many people here have SANs in their environment today? I'd say about 80–90%. So once you start using SANs, it's great. Like, they have all these tools and all these options, and you very quickly get used to, like, hey, I can do theme provisioning, and I can spin up a LUN, and people want to be able to use the same processes, the same tools, whether they're on a physical machine or a virtual machine. And so we expect a lot of people are going to be using this simply because it will simplify their management experience, and they'll be able to follow the same processes whether they're inside a virtual machine or they're outside of a virtual machine. And that's actually something that I'll just drill into a little bit and call out a detail on, is while we create a virtual fiber channel HBA, you'll see like the Microsoft virtual HBA inside the virtual machine, we do directly expose the LUN through to the virtual machine. So if you have utilities, tools, command line prompts, so on, that are specific to your vendor, so you have a Hitachi SAN, an EMC SAN, a NetApp, and they have a bunch of command tools, you can run those inside the virtual machine, and they work in exactly the same way as if you'd run them on the physical computer. What we need in order for this to work, however, is NPIV support in your environment. And this is simpler and harder than it sounds. Now, the simple part is NPIV is actually a well-established industry standard. It's been out there for a couple of years now. And we've been working with a number of vendors to get firmware updates and drivers in place for Server 2012. I don't have the list here, but we do have a list on the TechNet wiki where we're keeping track of what adapters we have confirmed working. But most modern adapters, HBAs, have support for NPIV. Now the tricky part is, and this is, honestly, this is the biggest mistake people are making when they're looking at virtual fiber channel, is in order for NPIV to work, you need three things. You need a HBA that supports NPIV. Okay, that's obvious. You need a SAN that supports NPIV. Okay. You need a switch that supports NPIV. Let me be really clear, NPIV does not work if you don't have a switch. And what we've actually seen a lot of is when people are just evaluating, they take their NPIV SAN, they take their NPIV HBA, and they link them with a cable. That doesn't work. NPIV doesn't work in that environment, and virtual fiber channel won't work. You need to have a switch. That is part of the NPIV standard. So even if you're just doing evaluation on a single box, you can't take the shortcut of not using a switch in your environment. So one thing that I want to talk through and show a quick demo of is that as well as providing all this integration with your existing SAN environment, we've done a lot of work to make sure that virtual fiber channel still works with live migration. So you can have a virtual machine using virtual fiber channel and live migrate it around. Now, it turned out that this was actually really hard to do. And the specific problem that we hit is in a traditional live migration, we transfer memory state across, we get things pretty much ready, and then we pause the virtual machine and we do our quick flip, and we flip over and we start up the virtual machine on the destination site. And one of the key assumptions that we have about making this work is that we can start up that virtual machine really quickly. Now, when you start looking at the world of SANs and fiber channel, unmapping a LUN, exposing a port, is not quick. In fact, on average, it takes about 30 to 60 seconds, depending on your HBA and your SAN vendor. Obviously, 30 to 60 seconds, not going to cut it for a live migration. So we came up with a bit of a novel approach. And what we do is, when you assign a virtual fiber channel adapter to a virtual machine, we actually allocate 2 worldwide port names instead of 1. And when the virtual machine first comes up, we have it run off of the first worldwide port name. When you select to live migrate the virtual machine, what we actually do is, while we're doing the live migration, and while we're doing the memory transfer, but before we get to the flip point, we actually use the second worldwide port name to expose the port to the destination box. And this allows us to have the 30 to 60 second. It allows us to confirm, like, okay, yeah, everything's fine. And only once we've done the memory transfer and we know that that LUN has been exposed to that box using the second worldwide port name, will we go ahead and do the live migration. And so what actually happens is that once the live migration is completed, inside the virtual machine, we will have switched from using the first worldwide port name to the second worldwide port name. Now, what will then happen is, if this virtual machine is live migrated again, we'll switch back. And we basically flip-flop between these 2 worldwide port names so that we can still live migrate. Now, for 99% of scenarios, this changing of worldwide port name has no impact on the system at all. it just continues to run. We did spend a bunch of time while we were working on this reaching out to people who write management software for SANs to basically say, hey, if you're running inside of a VM, this can happen. Because our fear there, and we did confirm this with a couple of our different SAN partners, is there is some software out there where if it sees a worldwide port name get changed without going through their own management system, they're going to assume that there are monkeys loose in your data center, and they're going to start throwing alerts and going like, hey, some moron changed the worldwide port name. So we've actually been working with those guys. So most of them are online for getting updates out where they're now able to go like, oh, okay, I'm in a virtual machine. These are the worldwide port names that I can expect to see. Apart from that, though, there's no effect to having this worldwide port name change, and it allows us to do live migration. So I'm going to do a quick demo of this, and I will apologize. I had hoped to do live demos. However, when I got here and I tried to VPN into my lab, the experience was more like a slideshow than a demo. So I'm using videos, and on top of that, I'm using videos that they captured at TechEd Europe, which they did not do a good job of, so they're a bit blurry. So I apologize for all of that in advance, but let me start this video off. So this video is actually demonstrating something that is both actually quite complicated, but what we expect to see most often with virtual fiber channel. Because what we have here is we have a 2-node Hyper-V cluster where we've got the clustering at the Hyper-V layer, but we then have 2 SQL virtual machines which have also been clustered inside the virtual machines through the use of virtual fiber channel. So as I said, this is a bit confusing. You'll see jumping around. So that was clustering in the parent, but now we're looking at clustering in the virtual machine. And you can see we've got VM Connect up here. We've got a NetApp exposed into the virtual machine, and it's got full access to that. We've actually got 2 LUNs exposed into this virtual machine. We've got it set up, SQL, one of those LUNs is being used for the log, and one's being used for the data. Here you can see that we've got the virtual fiber channel adapters configured on the virtual machine, and they're connected to the SANs that we created for them. And what we're actually going to do is we're going to simulate something that we expect will happen. We're going to have an active SQL workload that's running against both virtual machines. It's an active SQL cluster. And then we're going to need to do some hardware maintenance. So what we will do is we will do a live migration of one of these virtual machines off of the node. We'll evacuate the node. So what you're going to see here is we will choose to drain the roles on this node so that we can do some maintenance on it. Now the key things that you're going to see here is the virtual machine is going to live migrate, and the workload will never be dropped. The fiber channel will be remapped across to the virtual machine on the destination, and everything will continue to run. So it takes about 10, 20 seconds longer. There we are. So now it's reconnected, it's across. We've maintained the highest level of availability here because we have clustering both inside the virtual machine and at the physical layer, but we're able to use the same fabric for both of these environments. So great levels of high availability without needing to have separate layers for each component. So the next thing I'm going to talk about is unmap, and I know we covered this in the overview session, so I know this is going to be a little bit of repeat for people. But let me do a quick show of hands. Who here is familiar with the concept of trim and unmap in storage systems? Okay, only about a third, so I'll go over this and I'll just explain kind of the history here. So the first thing, which is very enlightening for people who are new to this, I was certainly relieved when I heard this. Trim and unmap are just different names for the same thing. What happened is we had two different branches of storage. We had the guys working on SSD and the guys working on SAN infrastructure, implemented the same concept and basically called it different names. So if you're talking SSDs, they say trim. If you're talking SANs, they say unmap. But it's essentially the same concept. And without going into the long and frankly boring history, with both these storage standards, they had different reasons for needing the software to tell it when it's done with something. So traditionally in a file system, what happens is if you go in and you delete a file in a file system, we don't actually delete the file. What we do is we remove it from our own software map. You know, we basically say, oh, okay, we don't care about what's there anymore, and if we need to write somewhere in the future, that space is now available. We mark it available, but all the content is still there. Now, this causes a problem for the storage vendors because they want to be able to do optimization, and they want to be able to differentiate between data that the operating system actually cares about and data that the operating system is done with and is never going to touch again. So trim and unmap are basically ways that the operating system can tell the underlying storage, yeah, we're done with that. We're not going to use that anymore. So what we've done is we have integrated this throughout the complete virtualization stack. So the first thing that we've done is we've integrated it into our new VHDX format, where when Windows is running in a virtual machine, if it sends trim and unmap commands down, we're able to perform optimizations in our own virtual hard drive. And you get this benefit running on any hardware. Even if you're running on hardware that doesn't support trim or unmap, you still get the benefit of us implementing this in our virtualization layer. But what we've also done is we actually send trim and unmap commands ourselves through to the physical hardware if the physical hardware supports that. And what this means is that if you're running virtual machines on a SAN that supports unmap, you're going to see a lot greater efficiency at space usage from your virtual machines. A couple of notes though. The first one is this is only supported for VHDX or pass-through disks. We don't support trim unmap on VHD. And it's also only supported on our virtual SCSI and virtual fiber channel adapters. So I have another video that I'm going to show you for unmap. Now I'm just going to show you unmap inside of a virtual machine, not unmap through to a SAN. As I said, time constraints limit what I can show you today. So what this demo is going to show is there are two virtual machines. The one on the left is using a VHD, and the one on the right is using a VHDX. So the one on the left doesn't have support for trim and unmap, whereas the one on the right does. And we're going to perform a couple of different file operations. And as we're doing this, we have this little monitor here that tells us how much space is being used by each of these files. So the first thing that we're going to do is we have a big file here with some data in it. And we're just going to copy it to another volume. Now I should highlight, you can see that these computers have an X and a Y disk. They're actually just partitions on the same VHD. So you're going to see that we use both of those, but it's all backed by the same storage. So when we copy this file to the X disk on both cases, you'll see what you would expect to see, which is you're going to see that the virtual hard disks grow in size as the data is copied to them. Now one thing that I will point out, I mentioned this earlier in the architecture and scale session. We do some extra pre-allocation of space on VHDXs in order to increase performance. So you'll see at this stage that the VHDX will be using a little bit more space. But you'll see that we make it up later with the support for trim and unmap. So now we've done this file copy. Both files are growing. And what we're actually going to do is, first, we're going to go and delete the file that we just copied. Now, as I mentioned, when we delete a file, Windows doesn't actually go through and remove the data. It just removes the reference from the file table and says that space is now available. So once we've deleted both those files, then we're going to run a command called optimize. And you can kind of think of optimize as defrag on steroids. In that with all the new storage stuff that we're supporting in Windows now, like trim and unmap, optimize actually goes through and gets Windows to do that straight away. Now normally trim and unmap is something that's done lazily in the system. We have to kind of kick it to make this demo work well. So what you'll see is in just a moment we'll open up a PowerShell window and run a command to do trim and optimize on both of these. And I will highlight on the one on the left, since we're running VHD, this isn't going to do anything, unfortunately, but we run it on both so that you can see it on both. So it's a PowerShell command to run optimize. And what this is doing is this is then going down, and because we're in a virtual machine, this is reaching down into the virtual hard drive stack and letting Hyper-V know from the guest operating system, hey, I'm not using this space anymore. So we run optimize on both, and what you're going to see is actually nothing happened. The size is going to remain the same. So at this stage you might be thinking, what's the big deal? Meh. What we're going to do now is we're going to copy that file again, but to the other volume. And what you'll see is that on the VHD file, it's going to grow in space again, because Hyper-V doesn't know that the old space is now available. So we're going like, oh, okay, you've got a new file to write. Let's write there. On the VHDX file, however, there will be no size change, because Hyper-V knows, oh, I've got this chunk of VHD already allocated that's ready to go that you're not using anymore. So you can see, second time we copy, VHD grows, the VHDX does not. And the other thing to highlight is, in this scenario, the VHDX actually performed a lot faster than the VHD. And the reason why was, because we didn't expand the VHDX, we didn't have to do all the allocations for that. The VHD, that was new allocations, slower performance. So the final thing we're going to show in this video is we're going to delete those files. We're going to run the optimize command again. And once we're done with that, we'll shut down both virtual machines. And this is the second integration that we've done with Unmap inside Hyper-V, is when we shut down those virtual machines, for the VHDX file, we will see, oh, there's a bunch of allocations that have been unmapped, and we will go through and we'll just instantly shrink the VHDX down to the space that's actually used. So we'll just close those down and shut them down. And what you'll see is when they turn off, VHD stays the same size, but VHDX back to the size it was at the beginning of the demo. So as you can see, you can imagine if you have, 80, 100 virtual machines running, people deleting, moving files around, using VHDX, you're going to get a lot more efficiency in your storage than using VHD. So now I'm going to talk about ODX. And I do apologize for the people who are in my earlier session. The next 3 slides are going to be repeated. ODX is a new technology that we're enabling in Windows Server 2012. And this is where we offload data transfers directly to the SAN rather than doing them in Windows itself. So historically, to move data around on a SAN, we would copy that data into memory on the Windows server and then copy it back to the SAN. This is very inefficient, especially with modern SANs, which have a lot of intelligence about what's actually happening with their storage. With ODX, what happens instead is we just hand tokens back and forward. So rather than giving the SAN the data we want to move, hand feeding it, we just give it a token that says, hey, move this data there. Perform this operation. And there are actually two ways that we've integrated this into Hyper-V. The first way is there are a bunch of disk operations that Hyper-V does itself. It does virtual hard drive creation, virtual hard drive merging, mirroring, so on. All of these operations have been updated to take advantage of ODX. So if you have an ODX-enabled SAN, for instance, doing a storage migration is going to be much faster than if you don't. The second thing that we've done, though, which is really cool, is if you have an ODX-enabled SAN, you've connected it to a physical box, you've created VHDs on there, you've created virtual machines with those VHDs, you're running Windows Server 2012 in those virtual machines. When you perform file operations inside there, that will also get ODX acceleration. So that's a high level of efficiency for storage performance. So I'm going to show a quick video which I showed earlier on, and this is the difference between creating a 100 gig fixed size virtual hard drive on an ODX enabled volume versus a non-ODX enabled volume. Now, for anyone who's created fixed size virtual hard drives of a decent size, you know that this is a very long running operation. So this script just uses our standard API to create a 100 gig fixed size VHD. But as you can see, we have one with the offload enabled and one without the offload enabled. Now, offload enabled, there, 2 seconds. Without offload, it will take, and I don't have the full video here, it does take 80 minutes. And because that's 80 minutes of us saying, okay, write the next 0, write the next 0, write the next 0, write the next 0. Whereas with the offload enabled, all we did was we went to the SAN and said, we need 100 gigabyte of zeros. And the SAN said, I have some zeros sitting around. Here, have them. So that's the difference there. One question that I have had a number of times now is, hey, is ODX new technology? Am I going to need to buy new SANs? The answer is kind of it depends. We've been working with a lot of the SAN vendors. There are a number of vendors who are just releasing updated firmware that has support for ODX. So the answer is really going to be, you need to go to your SAN vendor and say, hey, here's the model I have. Do you have an updated firmware that supports ODX? Thankfully, a lot of the vendors are releasing firmware for their existing models and not requiring people to buy new ones. It's on, it's going to be per vendor. Everyone that I know of, it's been on by default, but a vendor may choose to make it a switch. So, up to this point, what I've been covering is I've been covering what we've done to make existing scenarios better. Now I want to talk about what are some of the new scenarios that we're enabling that you couldn't do before with Hyper-V. So the first big one is Hyper-V on SMB. And I want to be crystal clear before I move on from this point. And I say this, by the way, as the Hyper-V PM. If you've spent much time around Microsoft, you know that we're very territorial and very combative and so on. SMB 3.0 rocks. It really, really does. Honestly, if the one thing that you do coming out of this session is go out and seriously have a look at SMB 3.0, I'm happy, because you should be looking at SMB 3.0. It is amazing what's been enabled in SMB 3.0 compared to what you got with SMB in the past. And I feel I have no hesitation in saying, hey, Windows Server 2012, SMB, it's ready as an enterprise-grade file storage option. Equally, and I've had people come and ask me this, if someone came to me and said, hey, should we be using iSCSI or SMB 3.0? My answer would be, honestly, I can't think of why you would use one over the other. Personally, I'd go with SMB 3.0 because it's easier to manage. It is really impressive. So, we now support virtual machines on SMB. We do require SMB 3.0, which today means I might get in trouble because there's probably a third person. I only know of 2 ways to do this. The first way, obviously, is a Windows Server 2012 server. The second way is I do know that NetApp has just released updated firmware for a number of their devices, which adds support for SMB 3.0. There are probably other partners who have done it. So I know we've been working with a lot of the vendors to make sure that SMB 3.0 support is coming out soon. But one of the things with supporting virtual machines on SMB is, and this has been something that people have been asking us for a while now, and it's actually been something that we've been working on for a while now. When we started working on Hyper-V, and we started looking at what it would take to support virtual machines on SMB, we actually identified a bunch of things about SMB where we said, you know what? Without this, we don't feel comfortable running virtual machines on SMB. And we've been working with the SMB team, and they've been improving the protocol to be able to address our concerns. So a big area of investment has been ensuring that an SMB share can deliver the sort of availability and resiliency that you need in an enterprise environment. And there are a number of ways that we've done this. The first one is handling intermittent network failure. So, raise of hands. Who here has ever had a situation where there was, and I'm sure this will be rare, I'm sure no one will raise their hand for this, had a situation where, who knows, firmware glitched something, but their network connection just went away for a moment and then came back. Has that ever happened? I'm shocked. It happens. You know, networking is very complicated, and it happens. You know, and it's often just this intermittent. You know, it went away for a second and it came back. And the only way that you know that it happened is because A, something broke as a result, and B, when you went and looked in the event logs, you're like, oh, the network went away. That sort of thing is potentially catastrophic for Hyper-V. You know, if the network went away for a moment and that was all your virtual machine storage, you know, the result would be all your virtual machines are bug checked. So we worked with the SMB team and we built in resiliency to this kind of failure. And what actually happens now with SMB is Hyper-V on SMB, if there's a temporary disconnect, both sides are basically able to go, oh, something's gone wrong. I'm going to cache. I'm just going to hold on for a little bit and see what happens. And if the network comes back, we pick up again. Now, we're actually able to survive a disconnect of up to a minute. So, hopefully you're not having disconnects that long in your environment. But, you know, we've built this logic in so that we can survive, like, if it's disconnected for a couple of seconds, fine. You know, you will see a performance glitch, you know, as we're caching and catching up and so on, but the system will keep on running. So the next thing, what about permanent failure? What if a link goes down? Well, one of the really cool things in SMB 3.0 is it now has native support for multi-channel. And multi-channel is able to handle seamless changes in paths. I remember, and I mean, for me, this was a big nerd moment. I had a tear in my eye. I remember, I'm not joking, when I had the first build of Windows on my laptop that had the SMB multi-channel support built in. And I didn't realize this, because like I'd been in meetings with the SMB guys and I knew that they were working on it, but I didn't realize that they'd got it into the build that I had on my laptop. And I started copying down an ISO from a file server on my laptop. And I'm sitting there watching it and it's just puttering in. And I'm like, huh? Oh, I haven't connected the cable. We're just going over wireless. I'm like, damn. I grab the cable and I connect the cable and then 2 seconds later, my speed goes up. I'm like, what? That's great. SMB multi-channel now detects when new connections come and go. It's seamless, and it gives awesome performance, because while all the connections are there, it does use all of the connections to get maximum performance. But if a connection goes away, it's able to handle that without any interruption to the workload. So the next one that we looked at is, what about making your storage highly available? This is also really cool. This is, and as I said, if I get nothing out of this session but you go and look at SMB 3.0, I'm a happy man. One of the things that we've done in SMB in Server 2012 works with Hyper-V, but it's not just for Hyper-V, is we now have transparent failover of SMB. So if you have a clustered SMB share and you have someone accessing files on it or a virtual machine running on it, and one of those nodes fail, then it will switch over to the other node with no downtime, with no interruption, with no disconnect. So you can have a 2-node SMB cluster, virtual machines running off of node 1, connected remotely. Node 1 goes down. We're going to immediately switch across to node 2. That virtual machine will not know that anything happened. That's just awesome. And there's been a ton of work that's gone into that. And as I said, that's not just for virtual machine, but also if you just do standard file share. And the final thing is supporting Hyper-V clustering with SMB. And this is something that is also completely supported. And in fact, it's one of the recommended deployments that we're now talking about, is having a Hyper-V cluster where its backend storage is an SMB cluster. We think that's going to be a very high performance, highly available, and relatively cost-effective solution that you can build with Server 2012. The final thing that we've enabled with SMB is we've enabled full support for VSS-based backup. And the real goal here for enabling this, and kind of the target that we set for ourselves, was that if you can do it on a SAN, we want to be able to do it on an SMB share. And this was one of the features that we went, hey, if you have a SAN, you have a great backup story. Let's have the same sort of backup story if you're using an SMB share. So from an administrative point of view, backup feels the same whether you're using a SAN or an SMB share. You still get your ability to take VSS snapshots of your virtual machines, even if they're running on a remote system. The question, how many snapshots can you take? I don't know. I know it's not a number. I know there's a calculation where the number changes, but I don't know off the top of my head. So 2 things to highlight, though, before we move off of SMB. The first one is, if you really want to get the best performance out of SMB, then you need to invest in the hardware. Hopefully that should be fairly obvious. Don't go sending up a box with a gigabit adapter and wondering why you're only getting a gigabit throughput. The best hardware that you can get is actually 10 gigabit networking with RDMA. That's a hardware offload that allows us to get awesome throughput for SMB traffic. The other thing just to highlight is multi-channel is the best way to get performance at. We fully utilize it for virtual machines. So if you're storing a virtual machine on a remote server, multi-channel is a great option. The other thing to highlight is, and a lot of people have made this mistake, unfortunately, and it's something that I'm sure many more will, is that if you're using Hyper-V with an SMB share, you need to set up the SMB share so that the share has permission for both your user account and for the machine account of the Hyper-V server. That's just a result of the way our security architecture works. So next I want to talk about storage spaces. So, quick show of hands, how many here have played with storage spaces in Server 2012? Not enough. Shame on you people who didn't put your hands up. So, most of you who have played with storage spaces have probably played with it in this configuration, where you're just using it on a single box, you have locally attached storage, and you can use storage spaces to create volumes. And that works, and that's fine. But where storage spaces gets really interesting is in some other configurations that we're supporting. The first one is if you have multiple boxes that are connected to a shared SAS JBOD. So this is actually a relatively cheap option compared to a high-end SAN. But what we allow you to do is if you have multiple boxes connected to a SAS chassis just running JBOD, you can connect that and you can create a simple storage space and do clustering on top of that. So that's a very cheap option that's available. We also support creating a mirrored space on top of in this configuration. However, the thing to be aware of is with a simple space, every node gets direct access to the storage. With the mirrored space, CSV redirection happens, which essentially means you're going over SMB from the remote nodes to the owner node. So if you're going to do this sort of configuration, our recommendation is you need to have a really fast interconnect between your boxes in order to make that work. The other new model that we're enabling is something that's called clustered PCI RAID. This is actually something new that's coming out in hardware, where we've been working with vendors like Intel, LSI, who've traditionally done, your cheap onboard RAID controllers to come up with solutions where those cheap onboard RAID controllers can connect to a shared SAS array. And one of the things that we've also been working on with vendors is a concept that we call cluster in a box. And this is something that we are expecting to see coming out to the market soon, where what we're going to have is we're going to have different OEMs selling one piece of metal, one chassis, but inside it, it's actually going to have two servers, clustered PCI RAID, storage on the back end. So you'll be able to get, a single unit that you put in your rack, you connect the cables at the back, and it's now a 2-node Hyper-V cluster in a box. So the final thing the second to last thing, I forgot there is a final thing. The second to last thing I'd like to talk about is some of the improvements in the virtualization stack itself. So in this release, we're introducing a new format called the VHDX format. Now, I've mentioned this earlier, but today we have VHD. VHD was designed 15 years ago for running Windows 3.1 on Mac OSs. So it's done quite well to get as far as it has. But there are a number of changes that are happening in storage that we need to respond to. The first thing is performance. We've done a lot of work to make the VHDX format higher performance than VHD. So here are some simple examples where you can see that VHD is consistently performing better, VHDX is consistently performing better than VHD. But that's just the first step. The next thing that's been happening is there's been a change in the industry to what's called large sector disks. So, show of hands, how many people are familiar with the idea of a 4K disk? That's good. I'd say about 50% of the room. So what's happening here is, historically, disks have always had a 512-byte sector map. And the industry is now trying to move to 4K sectors. So why? Well, the simple answer is you can get more efficiency out of the physical storage layer using 4K sectors than 512. So as we're starting to move to these larger sizes, like the 3 terabyte, 4 terabyte drives, 512 is not becoming workable. So we're needing to move to this different sector size. And people are doing this in two ways. The first way is called 512E. And this is actually what you most commonly see out there today. If you go down to the shop today and buy a 3 terabyte or 4 terabyte drive, you're probably going to get a 512E drive. And what this looks like is the physical hardware is actually using 4K sectors, but they've put some logic in front of their hardware controller to accept traffic coming in 512 byte format, and they actually do the calculation themselves and the conversion themselves. Now this comes with a significant performance impact. The second type of disk that's coming out though, and this we're just starting to see come out, is a 4K native disk. This is a disk which, if you try and talk to it using 512 byte sectors, it's just not going to work. You have to be able to talk using 4K sectors. So, problem. The legacy VHD format talks 512 byte sectors. So what happens today, it talks to 512E disks, and we don't have correct alignment, and you have to go through the hardware layer. What we've done is, with Windows Server 2012, one, we designed VHDX so that it does work just correctly with these disks. But we've also tweaked VHD just a little to make it work better with these disks. And this is, there are two things that you need to know here. The first one is, if you're curious as to what the tweak was, it's one of those cases where we were saved by a spec that had some ambiguity in it. We'd written in the spec that there was a pattern at the front of the VHD file, and we'd never specified what the size of that pattern was. In implementation, we'd always done it at 512 byte, which actually caused alignment issues. What we've done in 2012 is, when we create a new VHD, we make that pad bigger so that we're correctly aligned. But what does this mean? There are two things. First, if you have a third-party program that does VHD integration, theoretically it should work. We are compliant with the spec, but these VHDs don't look like other VHDs. So it may be possible that there will be a compatibility problem there. We've been trying to do as much testing as we can. The second thing to be aware of, though, is that this isn't something that we automatically do to old VHDs. So let me step this through for you. If you have Server 2012 and you have a 512E disk, you create a VHD file on that, it's going to perform well. But if you then take a VHD file that was created on Server 2008 R2 and move it across to your 2012 server, it's not going to perform well. It will not have the correct alignment, and we don't automatically fix that up for you. And to show you what we're talking about here, this is the performance difference that we see for a correctly aligned VHD file versus a not correctly aligned VHD file. So as you can see, for the large write operations, there's a significant performance impact. So this is something to be mindful of. The obvious thing to say is, if you use VHDX, this isn't a problem at all. If you're using VHDs, create them on Server 2012 to avoid this problem. If you have a VHD that's created on Server 2008 R2, you can actually bring it to Server 2012, and you can use our Edit VHD wizard to do a convert operation. And you can convert from VHD to VHD. It sounds a bit strange, I know, but if you do that, that will actually go through and correct the alignment. So then what about 4K disks, 4K sector disks? This one actually caused us a bit of heartburn, because one of the things that we realized was we could make VHDX 4K sector aligned, But if you then ran an operating system inside of the virtual machine that didn't know how to talk to a 4K disk, it still wasn't going to work. So the specific scenario we were concerned about was if we create VHDX and it's 4K sector aligned, but you then install Windows Server 2003 inside of that virtual machine, it's going to have a problem talking to that disk. So what we've done is we've done two things. First, we made VHDX be 4K aligned by default. That works if you're running a modern operating system, great. But second, what we actually did was we implemented our own equivalent of the 512E layer for native 4K disks. So if you have a physical disk that's native 4K, we will do the sector remapping in the software layer so that no matter what you're running inside of the virtual machine, it will work. Now, there is a performance penalty for that, but it will work. Obviously, your preference is, if I have a 4K disk, I'm using VHDX, I run recent versions of Windows Server that support 4K, and you get your complete native throughput. Final thing to mention about the investments in the virtualization stack is we've done a lot of work around online meta-ops. I'm not going to go deep into this apart from to say, hey, finally you can delete a virtual machine snapshot, and we delete the virtual machine snapshot. Thank you. So we're running tight on time. I'm going to skip over the next two slides because, well, the next slide because I covered it in my earlier session. There are some other things I do want to talk about on storage investments. And these are kind of related technologies that you should be aware of. The first one is the CSV read cache. This is something that the clustering team implemented for a very specific scenario, and in that scenario it works really well. One of the things that the clustering team has been looking at is people setting up VDI deployments, and one of the headaches of a VDI deployment is the boot storm. Everyone comes in at 9 a.m. and you try and start up everyone's personal desktop computer and it swamps the disk. So what the clustering team have actually done is they've implemented read cache on the virtual hard drives in CSV. And that causes a drastic reduction in the boot time for those virtual machines. But that's something that's only available if you're using clustering and CSV. The other thing that I'll call out, because I do get questions about this. In Windows Server 2012, we now have the inbox deduplication support. And there's a good and a bad here. The good is it's incredibly efficient for deduplicating VHDs. It's amazing. The bad is it only works if your VMs aren't running, which is kind of a problem. So we do not do deduplication for files that are being actively modified. So for Server 2012, where you're going to use this most is if you have a library server that's storing copies of virtual machines. Another great place to use it is if you have a server where you're storing virtual machine backups. You're going to get huge efficiencies in deduplication there. I do like to call this out, though, because everyone sees deduplication. They're like, yeah, I'm going to turn that on my Hyper-V servers, and we're going to save space. I was like, are your VMs running? If they are, you probably want to slow down. So, I've covered a whole lot of stuff here, and I know I've been jumping all over the place. That's kind of the nature of our investments in storage. We've invested on a lot of fronts here. So what I would like to wrap up with is I would like to wrap up with some example configurations. And these are things that these are deployments that we expect to be common. We look at what we see happening in the hardware industry, we look at what we've built in Server 2012, and we go, yeah, we think people are going to be doing this. So the first one is, we expect people to continue to use SANs largely like they're using them today. And something, as much as I love SMB 3.0, something that I'm very open about is like, hey, if you have an existing investment in SANs, don't go throw that out. We've done a lot of work to let you get more money out of that. So we expect to see people who are using SANs today with 2008 R2 continue to use them with 2012 and get more out of them. We expect to see those people using virtual fiber channel if they have guest workloads that need to be clustered. But for the most part, people in this configuration, their lives are going to remain largely the same, but things just got better because they now have ODX, they now have Unmap, they now have Windows being a lot more efficient in the way it uses their SANs. Then we expect to see some new deployments. So the next one that I'm really looking forward to is the cluster-in-a-box style deployment that we've got shown here. Of course, what I'm really looking forward to is if someone gives me one of these pieces of hardware for my house, but I've been told I'm not allowed to take it if they offer. But we're expecting, and what we're really expecting with the cluster-in-a-box is we're expecting to see these sorts of deployments taking off for things like branch office deployments, where you want availability, but you're not willing to spend the amount of money for having a SAN on site. And the final thing that we're looking to is people doing the really low end and the really simple kind of deployments here, just the 2-node Hyper-V server cluster. So with that, related content, how you can contact me. Please fill out evaluations, and the people who are leaving might want to know that I have a laptop to give away. What? No, I can't give it to government departments if you're leaving. So I do have, people keep on giving me laptops to give away, and they tell me that I can't take them, which is disappointing. So I do have an Aspire S3 here. So I have to come up with questions. That's a challenge. So I've been thinking about this, and I thought we would try and do a competition. And for the competition, I want to know who here has created the virtual machine with the most storage attached to it. So let's do a show of hands. Who's created a virtual machine with more than 2 terabyte of storage attached? Okay, more than 4? More than 6? More than 10? Okay, we're somewhere between 6 and 10. How much for you? 9? 7. You win. What? Are you telling the truth or are you lying? What? That's fine. Here. Come on. Huh? Free laptop for you. I'm not allowed to take it, so I have to give it away. So, we are at time, but I'm going to hang around for questions. Do we have any questions? Way up the back? So the question is, can you use DFS for the SMB storage? Yes, but with a caveat, and I do want to be very clear about this. You can use DFS, you cannot use DFSR. DFSR is very much like the deduplication story. DFSR does not work for online files. So I do have to address that because I would say about half the time when people ask me about DFS, they're actually thinking about DFSR. So DFS works, DFSR does not.
When you shut down that guest to thin out the VHD, is that shut down just to speed it up, or is it a necessary step?
So the question is, when we shut down the virtual machine in order to remove the space from the unmap command, was that a necessary step or was that just speeding it up? That is a necessary step. We don't do the unmap while the virtual machine is running. And specifically, we don't do that because we get better performance if we have a bunch of space sitting around. Now, you can actually cause us to do an unmap while we're running by going in and asking us to do optimization on the VHD. We expose that through the UI and through the PowerShell. But that's a manual step. So we won't automatically do that. So the question was, in regard to unmap, does reboot count the same as a shutdown? Yes, it does. Architecturally, inside of Hyper-V, we don't have the concept of reboot. anytime a virtual machine reboots, we actually completely turn it off and we create a new instance of it. So anything in Hyper-V that we'd only do on shutdown, we also do on reboot.
Can you VHDX boot a Windows 8 box?
So the question is, can you VHDX boot a Windows 8 box?
It's running down on the SSD with trim and stuff. It sounds quite good.
The problem I'm having here is, like, in all honesty, all I can remember is we had lots of arguments about whether you could do that or not, and I cannot remember what the outcome of the argument was. Send me a tweet on Twitter, and I will get you the response. I just have to go and look at my notes.
I'm sure I could probably Google up that.
Yeah, I think the answer is yes.
I never really thought about doing it until you talked about it.
I'm fairly certain the answer is yes, but I know we had arguments about it, so pushing my memory there. Any other questions? Yep. Do I know what vendors are supporting ODX? No, I don't know the definitive list. I do know, because I saw it on Twitter yesterday, I do know that NetApp has released a bunch of firmware updates that add support for ODX. I do know that we've been engaged with most of the major vendors, so I'd be surprised to find a vendor that's not supporting it, but of course they all have different timelines for getting this out. So with that, I'll say thank you for your time. Please feel free to come up and harass me, but I'm going to turn the microphone off.